Hi students, this is the fourth video in the series on column and in this is still for the pandas. I am continuing with pandas exploratory data analysis. Now the next step in data analysis is to do column of various different types of column operations using pandas. These are very powerful and include functionality such as addition of columns, deleting a column, renaming columns, adding a columns by various methods, and also conditional selection of a slice of the data set, and conditional selection. So let's get to it. Firstly, the easy ones, we can drop a column just by getting rid of columns that are useful for analysis using the dot drop method. And in fact, we have used it earlier also. We construct a small data frame for it. Right now, I won't go into the syntax for it, but let me just run it and you can see that there are three columns and 3 rows of data. Now, suppose we decide to drop column 1. Then what we have to do is df underscore small dot drop, and then we pass in the columns as equal to and pass in a list with the names of the columns to be dropped. And then we run it and you will see that the column has got dropped. If I wanted to drop more columns, I would just have to pass them in the list. All right. Now let's move on to adding a new column which is based on earlier columns. Now this is really useful because lots of times in analysis you may wish to synopsize or create new variables which are based on earlier, some combination of earlier variables. The syntax is df square brackets new column, so you just have to give the new column name is equal to df old column 1 plus old column 2. Now I'm doing a simple plus, but it could very well be a division, exponential, or any other kind of mathematical operation that you, or even Boolean operation. Okay, so suppose I want to create a column which is df1 YouTube likes percentage. Now what I want to do over here is define the YouTube likes. So df1 YouTube likes, which is one of my columns, divided by df1 YouTube views times 100. And if I run this and then do head, you will see that YouTube likes percentage column has been added over here. So this is a very useful functionality. All right. Now the next thing which we can do is how do you select a column. Now there are various ways of doing it, but one easy way, especially if you want to just select one column, is to just do df1 and square brackets and type in the column name within square brackets. This is known as slicing and is a very useful way to see a small subset of the data. Typically it's only done for seeing one column. Now, if we wanted to see a small, two columns, then we would actually need to pass them into as a list. So we have df1 square brackets, and then within that another square brackets, which is essentially a list which contains the names of the 2 columns. And if I run it, you can see that 2 columns have got selected. Now the next thing which we do is a very powerful method called the .loc method. Now this is an extremely useful method which returns to you various specified rows and columns. This is way more flexible than just simple slicing. You can add on lots of different types of conditions, which are row conditions, for example, to select the column. Now what is the .loc syntax? All right, the .loc syntax is basically rows, comma, columns. Now what you can do over here for rows and columns is you can specify the rows by the index numbers and the columns typically are specified by their names. So for example, if you see the syntax here, df.loc and we are selecting from rows 0 to 5 up to 5, comma, and we are doing this for column 1. So from column 1 we are selecting the first 5 rows. All right, now let's just do an example, df1, and we wish to select all the rows from 0 to 9. So when we run it, we get all the rows from 0 to 9. Notice that there are no column names mentioned. If there is no column name mentioned, it generally means that all the columns will be included. Now let's do a slice of the data set. A slice basically means we are taking a small subset of the data set. Here we are specifying with .loc that we want up to 5 rows, and we want it for the following 3 columns. So we pass in the columns as a list. Genre, movie content, and director categories. If we run it, we get the first 5 rows and 3 columns that we have passed in as a list. Now, as an exercise, let me just demo you a few other uses. Now, suppose we wanted to select just one row. Then we can also do df1.loc square brackets and just mention the row index number, which is 100. And if I run it, we will get the entire row. All the columns are displayed here, and against them you will have the data just for one row. Now suppose we wanted to select multiple rows which are not in a sequence, so you can't use a range, and multiple columns. What you would do is you would pass in a list of the row indices 40, 50, 60, and a list of the column names. When you run it, you get basically 40, 50, 60. We get these 3 specific rows which are pulled out and 3 specific columns which are pulled out. Now, one very useful use of .loc is for row selection with conditions. Now, this is very powerful because you can use it to, for example, filter out rows which contain a particular brand, for example, or all the rows which have said yes for something, or all the rows which have said no for something. So it's extremely useful. So one example might be, we wish to see a condition where, for example, we wish to choose a condition where the success failure variable of the movie notes that it's equal to 1. So df1.loc, within it we pass in df1 and the column name, and then we put in the double equals sign saying that every row should be equal to 1. So this is selecting all the rows. Now notice this success failure is equal to 1 is where the 1 is coming in quotations. The reason for this is, recall that we had converted the 1 to string, and therefore it needs to be put in inverted commas. However, if it was numeric, then you would just leave it as it is. All right, so we run it, and as you can see, if we go over here towards the right in the success failure variable, all of the rows selected are the ones which have got the movie as a success is equal to 1. All right, then so how it works is df1 success failure is equal to 1 is basically the condition. This is the Boolean condition and creates a series of true or false values, and this is applied to the actual column to filter out the columns. Now suppose we wanted to select all the movies for which box office collection is greater than or equal to 100 crores. What we would do is df1.loc and then square brackets, again df1, box office collection is the variable, greater than or equal to 100. And as you can see over here, okay, let's go back here. This is always greater than 100. Now let's see some other examples of conditional selection. One is df1.loc. df1 for genre is equal to romance. So you can do this double equal to sign for any categorical variable as well as numeric variable. All right. So again, we have selected romance over here, as you can see. Now you can also do compound conditions. That is to say, not just one condition, but two conditions. df1.loc, and this is the super square bracket. Within it, we have the first one within round brackets. Each separate condition is bracketed off using round brackets. df1 movie content is equal to masala, and df1 success failure is equal to 1. So if you run it, you can get all the movies equal to masala, and success failure, let's just see success failure. Success failure is equal to 1. So I hope this video helps and is able to help you to get to understand .loc and other column conditions really well.